Okay. Yeah, I think I'm live. Right? I think I'm live on both places. And I'm live on 3 places. So that's my Twitch. That's my YouTube. Let's go to live. How do I change edit? Okay. 3D printing desk accessories. Well, save, that's fine. Let's move this here. Move this over here. Okay, we're live everywhere. Now let's go to screen recording. And this looks fine, right? Finish sketch. Any sketches added? No. Can I delete this? Yep. I create sketch. Yep. Here we go. Okay, I need to tell you what the plan is. No? Okay. So here's my iPad. And here's a mic stand. All right. The plan is to put it on top of here. And once it is there, I can just move it around and just keep it like this. And then just right on top of it so that it doesn't take up space on my desk. And I feel it is also like a complex enough project that I get to know more about 3D printing, but not so difficult that I can't do it. So it's kind of the good middle ground. Well, that depends on how easy it actually is, because I think it's going to be super easy, because I don't want to make it too much complicated. But holy fuck, what happened? I just hope the parts that I'm planning to print are actually as easy to print as I think they are. I'm not sure how easy it's actually going to be. I also have these small magnets. Let me just screenshot and then show you what I mean. It's all right. Let me close this. Yeah. All right. So the plan is that we have a screw here, right? And we have a iPad over here, and we need to attach it, and also we need to be able to detach it. So the plan is that we put 4 magnets over here. All right. And then we make something that screws on to this. So let's say something like this. So something like this. And we have magnets over here as well. And once this is screwed on, I can just stick it on and pull it out. Why does everything that I say about 3D printing turn sexual? The fuck? Anyways, you get the point. I need to be able to put the iPad on the stand and then just pull it off. and it should be easy enough. So that is the current plan. And again, we have the trusty calipers, and we have the, we need to measure how big the whole thing is going to be. And then I'm going to make indents for the magnets to put inside the thing. So I'm thinking somewhere around like here, like this big of a thing. So something like this. So yeah, around 60 mm. Yeah, it's 60.2. I'll just do 60. Yeah. And then I'll also need some space. So I need to measure what's the diameter for these magnets. So this 9 mm, 9.9 mm, so 10 mm. So 10 mm is the diameter for the magnets. All right. So basically what that means is if I start sketching, or if I can fucking, yeah, if I start sketching, and let's say I draw a rectangle, right? So this is 25, 25, 60. We need 60. Anyways, like, you see, this is 50 by 50, right? And we're going to need a 10 mm spacer to put in there. So what I'll do is just do a 60 by 60. There you go. All right. And I need to be able to move this. Is there a move tool? How the fuck do I move this? Constraints. Create. How do I move it? So how to move sketch in Fusion 360. Move sketch. Why is it so loud? Oh, sorry. It's probably just loud for me. Is it?
How's it going, everybody? And welcome back to another Fusion 360 tips and tricks tutorial. Again, post has happened, but it has gotten a lot of views, and it's. Let's click OK.
Did you move it already?
Of value. So let's just start moving it. Right, it's 5 years later. Okay. 60 millimeters to the left. Let's click OK. So that didn't do anything. So what I suspect, and it looks like the first comment here. Looks like Innovate Nate calls out, I suspect that you're creating the circle at the origin point. Does this sound correct? So that's my suspicion as well, right? He probably has just a coincidence, and there it is. He has a coincidence constraint right at the middle. So let's go ahead and delete this. When I went ahead and created this circle, I'm actually creating a coincident constraint right at the origin of the sketch. And what that prevents me from doing is when you right click on it and then move, it's following the rule that was set in place prior to trying to move it, right? So it's going, okay, yeah, we'll give it a shot, and maybe we need an error.
Wait, I can just right click and move. Move. Oh my god, bro. Move type. 5. Is it equal? Looks equal. Oh. Oh, that's cool. That's cool. Edit sketch. Okay, that was helpful. That was quick. Good guy. So we just had to right click. I'm just probably blind. Okay. Where do we go next? So can we bevel these? Five. If I do 2. Two mm. I'm trying to put in fillets, but I don't really know what it does. Anyways, so this is the overall like the whole thing, right? Now let's say I need a so how many magnets do I put over here? Because I need to stay in the same orientation that I have it. So 1, 2, 3, 4 should be fine. Or do we do 1, 2, 3, 4, 5, 6, 7, 8? That's too many magnets, no? How many do I have? Like I have way more than 8, but still. One of the magnets broke, dude. I don't know how do magnets break. And it's still sticking everywhere. Like, yeah, like the broken pieces are magnetized, but still. You know, have a look. See? Oh, holy, what the fuck? Why is it sticking to my monitor? See? It's broken. Oh my. So what's happening is like, I want all the broken pieces to be stuck to the one that is broken. And I can keep it separate. Because I don't know how magnets work. Anyways, I have these many magnets. That's pretty long. That's what she said. I don't know what to. Like, how many are 8? 1, 2, 3. How many are 8? Wow. I sound like a second grader, dude. 1, 2, 3, 4. 1, 2, 3, 4. Dude, fuck off. This broken magnet just. It's too clingy. I don't like clingy relationships. That's 4 magnets. Do I be like triple sure and just use 4 magnets? Or is it overkill? It's not that many. I got like 60 or 50. I'm not sure. Let me check. I'm not going to show you my Amazon history. Let's see. I got 50 and I'm using 8 in one. I already broke one, which kind of works, but I have like 42 left. Am I going to make something else? See, there are like a few things I need to make and then I'm fine. I don't know. Ah, fuck it. I'll just make. Fuck. You know what? I'll just put an 8. It's fine. It's fine, dude. It's fine. All right. So that's like 10 circles. Let's see. So now you see the thing, right? So basically this is like 5, 5. And if I write in 10, so this is basically 5 far from the thing. Dude, these are huge magnets then, no? Because if I'm gonna place like 8 of these in a 60 space, which is huge, by the way. Hey, it is huge, all right? It's decently sized. Can I mark it somehow on the iPad thing? Dude, it's a pretty chunky block of plastic that I'm gonna stick on it. I have super glue for it, but I can do 70, but 70 would be too huge, no? And that just adds extra weight. And that's barely any weight. That's going to be like 2 grams or something. That's like huge, dude. Like the magnets might as well just fucking stick to... Dude, no, wait, okay. No. We cannot do 8 magnets on just the plate. Because then that'll be 16 magnets on the whole thing. So I had to do 8 magnets total. Because 16 is just too much, man. It's just a stand. So can I move this? Move it to the left by 5 Is this? Which one's copy, brother? Move item. Why aren't there any tooltips on this shit? Now suddenly there is. Grade copy. And what is Z axis? Okay, I need to do Boolean operation, by the way. I need to also measure the height of the whole thing. So what I'm thinking is basically, if I extrude this shape, it's going to be hollow all the way. But I need it enclosed on the top and the bottom as well. So the problem is I don't know how to do that, because then basically I'll have to duplicate the sketch for the rectangle, start or like make the whole shape, then make 4 cylinders, put them in the middle of the rectangle. Yeah, put them in the middle of the rectangle and then exclude it, like subtract it from the whole thing. So the height is 2.7 mm. There you go. Dude. Okay, holy fuck. Dude, magnets are so strong. Okay. How about for now, let's just move, select, just create copy. Y can be 40. Move and copy. I selected this. Why would it unselect it? -40. Okay. Move and copy. X distance 40. Negative. Cancel, wait. Why wouldn't it create a copy? -40. Okay. Okay, finish sketch. Now let's say I want to extrude this. So extrude. Okay, now how much was this space? So you see how it's a hollow thing with 4 holes in it? I want this to be like 2.8 mm tall, and then I can super glue it. Or I can just make it 2.7, 2.8. Feels fine. Yeah, I showed you 2.7. I'm gonna leave 0.1 millimeter of distance so that I can place it in. So 2.8 mm. But how about ow, ow. How about how do I do this though? How do I do this? Sketch. Let's make bodies. Let's remove this. Let's make a say 1 mm sheet. The whole thing. So let's do can we duplicate this? Oh, cancel. Okay. Can I not just duplicate it? Because then I can... Okay, no, that's fine. I'll just create a new sketch. Yeah, I'll just create a new sketch. Like so. And then fillet the corners as 2. Do the same here. And do the same here. As well as here. Now that's sketch done. What you can do is hide this. And just... Let's just extrude this. So what height was it? 2.8? So we have 4 of these. Let's select this whole thing. This is 2.8, right? Huh? I don't want the area. Okay. So let's extrude 4.8 mm. Eight. And then let's move them up by 1 mm. Appearance, texture map. I am trying to find how do you boolean them. Is it under construct? Boolean operation and Fusion 360.
Welcome back to intersect, join, and of course the cut in Fusion. All the Boolean operations that is there that can intersect, join, and of course the cut in Fusion 360. So
Oh. Right. Well, I think I did something wrong, bro. Okay. Hear me out. Okay, what if I extrude this by 2.8? All right. And then this body too, right? And what if I then move it 1 mm up? Here we go. And then I open sketch 4. All right. And then I do extrude 1 mm. An operation join. This body too, right? So I open sketch 4 again. I open body 2, move, rotate, body 2, bodies, 1 selected. What do I select? What do I select? How do I? It's 1 plus 3.8. So how do I see if I still have the holes inside or not? Let's just try exporting these as an STL file. Export. Let's try and open a Blender and see what happens. Delete file, import STL, downloads. That tab How do I? Okay, seems like there is. I can see the faces. I can't see the indents. Now I need to repeat this. Okay. That's it. Okay, the shape's great. Good job. Good job, guys. Now I need this body. So let's just rename this shit. I'll rename it to iPad plate. I need to do the exact same thing. But now I need to do I just put it for print and then figure out the next step? Because then I can check if this works or not without putting it so much work. You know what? Might as well. No. Might as well. File, 3D print, 3MF. Selected. Okay. Yeah, files, iPad, wait. Save. File, open, 3MF. If I just, yo. I just watch a video to make sure how to put magnets in 3D prints. Top 5 ways.
Number 1, standard press fit. This is probably the easiest way to add a magnet to your design. Just make it cut out about the same size as the magnet and press fit it into place. This works okay as long as you have a well-calibrated printer. Some drawbacks to the design is that the magnets are difficult to insert if your printer doesn't have good tolerances, or the magnets might be too loose and easily fall out of the socket. You can always add some glue to the magnet to keep it in place, but I think some of the other ways to add magnets are worth considering before you get out the super glue. Another issue is that the magnets are difficult to remove if they're repelling each other. Number 2, press fit with a wall. This is pretty similar to the standard press fit, but with one exception. There's a dividing wall between the magnets. One benefit to using this design over the standard press fit is that the magnets usually don't fall out since the magnets are being pulled deeper into the socket instead of out of the socket like with the standard press fit. Besides not being able to flip the magnets around, this setup also reduces the strength of the magnets since there's plastic between them. So be sure to use strong magnets for this to work correctly. Number 3, blind pouch. Unlike the first two options, using a blind pouch or blind channel for the magnets prevents the magnet from being able to come out. Basically, you make it cut out where you push the magnet into place. For this to work, you'll need to add a small amount of tolerances for the part that will require bridging. Another tip is to make sure the wall where the magnets are attracting each other is as thin as possible, similar to the press fit with wall example. Around 1mm thickness is what I usually shoot for. This works out to about 2 layers of plastic. Like the push fit, it's usually pretty difficult to remove the magnet if you get the polarity wrong without destroying the print, but overall, the magnet is more secure using this method. Number 4, overhang. The overhang method is a method I recently started using on the Sumo enclosure that I've been working on for a while and it's worked well for me. The idea is that you essentially add a 45-degree overhang at the end of the channel to keep the magnet from being pulled out of the part. The benefit to the 45-degree angle is that you can print from any orientation without worrying about supports. The reason I like this method is that it allows you to easily flip the magnet around by pushing it out of the part if you put it in the wrong way without having to reprint the part. For the overhang, I've been using an offset of 0.8mm and extruding out 0.8mm of height so I can apply a 45-degree chamfer. This works out to 2 layers with Prusa XL at 0.4mm layer height, or 4 layers printing at 0.2mm layer height with a Prusa Mark IV or other printer. As far as the clearance goes, I've been making the cutout about 0.2mm bigger than the magnet. Number 5, print balls. This method is pretty much the same as a bomb pouch, except this time you trap the magnet from all directions. The way this works is you create the open space for the magnet and then polish your print before the hole gets covered up. You insert the magnets into the print and then resume the print. The benefit to this method is that the magnets are invisible once the print is done, but if you get the polarity wrong, then you have to redo the whole print. I've used all 5 of these magnet integration methods in my designs throughout the years, but but the one I use most often now is the overhang method. I like it the most because it lets you reorient the magnets if you need to while still looking good and keeping the attraction between the magnets strong. Alright, so that's about it for this video. If you have any questions, leave them down in the comment section below, and if you like this video, be sure to check this one out right here. Thanks for watching.
So just
Magnet strong.
pause it.
All directions. The way this works is you create the open space for the magnet and then pause your print before the hole gets covered up. You insert the magnets into the print and then resume the print. The benefit to this method is that the magnets are invisible once the print is done, but if you get the player on, then you have to redo the whole print. I've used all 5 of these magnet integration methods in my designs throughout the years.
Brother, these
The
are
one I use
too
most often now
strong.
is
I
overhang.
can't keep them apart. I'm trying to keep them apart.
Here's 5 ways to add magnets to your 3D prints. Number 1, standard press fit. This is the most basic way to add magnets, but you better get some super glue or your magnets are coming out eventually. Number 2, press fit with wall. By adding a wall and pressing the magnet into the part from the opposite direction, this method keeps the magnets in place but reduces the holding strength between the magnets. Number 3, blind pouch. This is a pretty concealed way of adding magnets but requires a printer with tight tolerances for bridging or the magnets won't fit into the pouch. Number 4, overhang. The way this works is by using a small chamfer that creates a rim so that the magnet doesn't fall out. One reason I like this method is because it keeps the strength between the magnets.
Dude just made. Oh god.
Hello everyone and welcome back to an exciting 3D printing tutorial. Today I'm going to show you how to embed magnets into your 3D printing, but I'm going to take it a step beyond that and show you how to completely cover those magnets using 3D printing as well. It's a really cool technique that Advanced Creative, not Creative Fusion. The magnets that I'm using, one is at 6.2, cut of space there, as it's not going to be strong enough for the magnets to attract to each other. It does 3 mil. The next stage is I've used the first sketch to cut, and I have made a cut of negative 2.4 millimeters. So the magnet does only have a height of 2 millimeters, but just with the nature of 3D printing, you want a bit of space there, just in case. You don't want the tool head to be stretching over the magnet if it's sticking out too much. So you want it to sit down a little bit, but obviously not too far, otherwise it's not going to be strong enough for the magnets to attract to each other. So I recommend either 0.4 or 0.5. In this case, I've done 2.4 millimeters for a cut. Then I've just extruded a 0.5 wall on the top. So when you do your printing over the top of
Wait.
6.2, one is at 6.3. This way I can put a magnet in each one and just see which fits best. So I've done one is at 0.1 increments. So here I've done 3 circles, one is at 6.1, one is at 6.2, one is at 6.3. This way I can put a magnet in each one and just see which fits best. So I've done a quick little sketch like that. I've then extruded it. I've only extruded it a little bit because I want this to be a pretty quick print. So I've just extruded it 3 mil. The next stage is I've used the first sketch to cut, and I have made a cut of negative 2.4 millimeters. So the magnet does only have a height of 2 millimeters, but just with the nature of 3D printing, you want a bit of magnet does only have a height of 2 millimeters, but just with the nature of 3D printing, you want a bit of space there, just in case. You don't want it to the tool head to be stretching over the magnet if it's sticking out too much. So you want it to sit down a little bit, but obviously not too far, otherwise it's not going to be strong enough for the magnets to attract to each other. So I recommend either 0.4 or 0.5. In this case, I've done 2.4 millimeters for a cut. Then I've just extruded a 0.5 wall on the top. So when you do your printing over the top of the magnet, I recommend at least 2 layers. So if you're printing at 0.2 millimeters, you'd want 0.4 space. In this case, I've just gone 0.5. Again, you don't want 1 mil thickness or 2 mil thickness, because then you also have the other side of, if you're going to have 2 of these printed, and if you had 2 mil height and 2 mil height, then you got 4 mils between, and the magnets are not going to attract very well. The next thing I did was just create some thickness, because 4 space, the magnet 0.5. In this case, I've done 2.4 millimeters for a cut. Then I've just extruded a 0.5 wall on the top. So when you do your printing over the top of the magnet, I recommend at least 2 layers. So if you're printing at 0.2 millimeters, you'd want 0.4 space. In this case, I've just gone 0.5. Again, you don't want 1 mil thickness or 2 mil thickness, because then you also have the other side of, if you're going to have 2 of these printed, and if you had 2 mil height and 2 mil height, then you got 4 mils between, and the magnets are not going to attract very well. The next thing I did was just create a sketch on top, just some text, and then I extruded that text so I could easily identify which magnet was which tolerance. So there's 0.1, there's 0.2, there's 0.3. The next thing we do now, I have set this Studio Open to layer height. It's making the next layer. We can find the layer where it will fit, and here, so you can see as this prints, it's going up, it's making the hole for the magnets, and then right here is the final layer where you want to drop the magnets in, and then the next layer it starts printing over the top, and then the final layer is one more layer over the top. So how do we get it to stop so we can put our magnets inside? Well, first you need to slice the plate. Then you need to scroll down or up and down until you find the layer where it transitions between the final layer and the next layer where it actually goes to the top. So you want to go one back, and then you right click over on this plus button, and you can add a pause. So what that is doing is it's going to add some G-code where it pauses the print. It'll send the tool head or the print head to the back corner, so you have some room to work on it, and then you can drop your magnets in. Because this is a pretty small print and I don't want it to be coming off, I also want to just add a brim to it. So I might go back to prepare, and I always forget where it is. So I'll go to global and just search for brim. brim type, and it's highlighting it for me. So I want to set that to outer brim, and then just slice plate again. So that's all done now. It's got a brim on it. It pauses here and then it continues. Also, one more thing I need to do, we need to make a second one of these so it can magnetize together so we can clone it. So we're just going to clone this one once, auto arrange, alrighty. And I probably want to put a little bit of spacing between these as well. And then we're going to also move it towards the front of the build plate, as this is just going to make it a little easier to access. If it was right at the back and it's pausing and you're trying to put the magnet in, it's quite difficult. So bring it to the front as much as you can, slice plate one more time, and this would be ready to go. And it's going to pause at that point. We can drop our magnets in, make sure they fit, see what the best tolerance is, and then resume, and we'll do those final 2 layers. So we can print plate, we'll send that over and we'll see how it goes. Okay, so our print has hit our pause point in the G code, and it's time to put our magnets in. We need to make sure the polarity is the right way. So this is why we've marked it, and I can put in one of the magnets. Because this is a test one, I'm trying the 6.1 diameter and it was too difficult, so I went straight to the 6.2, which needed a little more pressure, but I was still able to push it in. And then the 6.3 millimeter, that just dropped in, but there was really nothing holding it in place. And same for the other side, I went straight to the 6.2 millimeter and pushed that in, and then to the 6.3. Keep in mind that I had to reverse which way the magnets were facing, because when the two parts are brought together, they need to attract each other. Once the magnets are in place, we hit resume and the nozzle will start heating back up once it's to the correct temperature.
Okay, so I'll just probably have to. So add a pause. Do we just say fuck it and rip it? It'll take 24 minutes. Dude, let's just see. Let me just open my window. Okay. Now my main worry from the whole thing. It's checking the bed leveling, which is fine. It says 24 minutes. Let's just see the whole video.
You'll notice it starts moving again, and you'll notice straight away we've got an issue. So quickly stop, and let's take a look at that again. So what happened here is that the magnets are attracted to the hot end, and it's kind of skipped over the top and ended up moving over to the other magnet. So that's where I had to stop the print, and we can see that we're gonna have to try something else. Taking a closer look, we can see the 3 holes. So the 6.1 I couldn't fit it in, 6.2 I could, and then the 6.3 was the one where the magnets jumped out. And you got to be careful with these little buggers, they flick around quite a bit. So here we can see the 6.2 millimeter, it's pressed in, they're not coming out because the tolerance is really tight. For those 6.3 millimeters, it's just not tight enough. And so the magnet is just dropping out. When the print head goes over the top, it just lifts it out and then ends up getting stuck to the other side. So I think we're going to have to redo and just stick to the 6.2 millimeter magnet size. So here I've made a new model, and these are just using 6.2 millimeter holes. I'm pressing the magnets in, and it takes a little bit of force, but you can still manage to get them in. Sometimes they're a little tricky, and you just got to make sure that they are facing the right way and then press down on them so they fit in. Hitting resume on the print will cause it to start printing again once the nozzle is heated up, and it will start printing over that final layer. As we can see, because it's press fitted into the 6.2 millimeter hole, it's not jumping out this time, and it's printing directly over the top without the magnet jumping out. It only needs to do 2 layers, so this is doing its final layer over the top, and it will then be completed. And we can pop this off the build plate and then take a look. Once we remove the brims, we can now give it a test, and perfect. So it attracts to each other quite strongly, and we can move on to something a little more complicated. Now we can start moving into a proper design. We know that our tolerance is going to be 6.2 millimeters by 2.5 millimeters, and we can apply that to an actual model. And what I've designed here is just a simple little jewelry box. It's a smaller one, so it's not going to take too long to print, but it's going to use what we know so far. So all I've done here is designed a base and then a top lid. This isn't really a tutorial on how to model in Fusion 360. It's more about how to apply this embedded magnet technique into your prints. So I'm going to sort of assume that you know how to do some sort of modeling and apply these techniques in your own way. So what I've done here is just made a simple box, shelled it out, and then filleted around the edges. If we take a look at a section analysis, you'll see how I've created it. So we'll pull this back. So here we have a section analysis set up, and you can see our magnet cutout is just below the surface, and I'm going 2 layers high. Again, I'm using a 0.2 layer height, so it's going to be 0.4 above. In Fusion, to create this hole, what I've done is I've created a sketch on the surface of where I want the hole, but then I've set the start point to offset from that layer, and it's going to offset 0.04 in the negative. So that's where it's going to start cutting out. And then I've made my cutout 2.5 millimeters. So it drops 0.4 and then it cuts 2.5. And it does that in each of the 4 corners. And it's the same for the lid as well. So whatever you design, whether it's a box or a fridge magnet or something that needs magnets inside, that's pretty much what you'll do. Create a cut feature, but make it start from a certain layer down, so negative 0.4 in my case, and then cut into your material again, 2.5. And then from here, once you have your model complete, you'd send it over to print. So in Fusion, we go File, 3D Print, and I've set it up as a custom print utility, so it's going to go straight into Bamboo. I want my entire model, and I'll go OK. And then we just wait for Bamboo Studio to load up. With Bamboo Studio open, and it's about to load into our file, but it's going to ask us, do you want to load this as multiple parts? So we say yes. And here is our box. We first need to right click on this and split it. And this isn't going to be the same for every case. It depends on the model that you're making. I'm just sort of showing you the workflow for this particular model that I've made. So I've split it and I can auto arrange. I do need to flip this lid around. So I'm going to push F on the keyboard for face. I'm selecting that object first, then F, and then hit the top face. And that's just going to flip the face that you select onto the build plate. I also need to arrange these a little more so it's closer to the edge so I can access it easier. And probably better to do that from the top view, so I can go Control 1 to go into a top view. And I'm just going to drag this part over here and this part over here. Checking our print settings, we've got 0.2 for our layer height. Our strength, I'm just going to go for 2. Normally I'll do 3 for something like this for a bit more strength, but it's just a fast print, so we just want 2. I can change my infill down to 10% because it's not going to really be that strong of a part. I don't care too much. And I'm not going to use a brim for this model because it does have a fairly large base. I don't think it's going to need it. Now we need to add our pauses. So the first thing we can do is go to slice plate, wait for it to load. We have our first stop is going to be on this area, and then it's going to continue printing, and then it's going to stop over here and then finish. So we need our first, dragging it down until we can see it, and then just using the up and down keys to get to that final layer. So we can see that's the one where it's going to print over the top. We need to go one back from that. So this is where we need to add our pause. We can right click, go add pause. Now to add a second one, we need to slice again. So we slice, and the next one's going to be all the way up here. Okay, so that's our final top layer. We want to come one back, right click, add pause, and then slice plate. And this would now be ready to send off to print. So all I need to do is print plate and wait for it to pause, and I can add the first magnets in and then resume, wait for it to print the rest and pause, and then put the last magnets in and then resume, and it'll finish off and we are done. So let's start the print and see how we go. So here we have the first pause in our G code, and I'm inserting the magnets into the box. You may notice that the box is positioned at the back of the build plate, and that's only because I filmed this in a bit of a different order, but learning from my mistake, that's why I showed in the slicer to move it to the front of the build plate so it's a bit easier to access. Anyway, the 6.2 mil tolerance holes weren't too difficult. It required a bit of a press, and I was worried that I might upset the Z offset of the build plate, but it seemed to be okay. Once the magnets were in place for the first part, I then resumed to continue into the second pause. Now here we are on the second pause in the G-code, and you can see I'm struggling with putting the magnets in a bit more. I think this is because there was a little bit of a wait between where it actually paused and things cooled down a bit, and I think that may have constricted the tolerance a little more than
Okay, the A1 Mini camera is trash. I can see below my bed. The fuck? But anyways, you can see what's kind of going on. But it's mostly for just monitoring if in case something goes wrong. So it's basically 5 layers of plastic because it's 0.2 layer height. And then I did 1 mm on both the sides, and then the height is 2.8 mm. For this. Let's see if this will work. I don't know. I don't know. I'm thinking maybe 1 mm's too much. I can sand it. Yeah, I can sand it if I feel that there's too much space. I can just sand it. There is a pause in between. From what I remember, yeah. At 16 minutes, there's a pause. And that's just how big these are. No? I left 10 mm. Right? Yeah, 10 mm. Anyways, now the main question is how the hell I can do 0.5. Play, press, pull. So let's say I extrude this. Wait. Let's measure how deep the screw is. So it's around 12 mm. Let's do 12 plus 3, 15. Let's do 15 mm. No? 15 mm. Can I make it smaller? All right. There's a pause on layer 19. Yeah, there's a pause on layer 19. It's layer 17. So I should technically there we go. This. This over here. Taking this. I'm not sure if the fan stopping and starting again, is it like for cooling or if it's the magnet interfering. You know what might be funny? What if? Okay. You know what will be funny? If, let's say these are two magnets. Now, my whole thing was I need to be able to like rotate this and like watch it in landscape mode if I need, right? Let's say these are the four magnets, right? So for that to happen, it needs to be north, north. And these are, let's say this is the plate and this is the holder, right? So this is south, this is south. My issue is, what if now this is fine. Like if and these are like north south north south. What if the magnets are like south north south north and this is north south north south? Because now when I flip it, this is going to be north north, so it's not gonna stick, and then it doesn't work because it would. Dude, I'll have to check it right now. Dude, if that's fuck, why aren't I don't know, man. They could probably write it somewhere. There's no indication whatsoever of what is north, what is south. Fuck. How much is left, bro? One more layer. I'll check it. I'll check it. Till then, I had to figure this out. Like, how do I make it? Make a pyramid in Fusion 360. Yeah, Fusion. Yeah, it's a
For this video,
thing.
which is the bottom place. So I'm going to make it before you sketch on right over the and I select that loft to make profiles. I point if I go to the loft tool and I select those two profiles.
So that's how you're supposed to do it. So, okay. Let's remove this body, delete it. And there's the final, there's that thing. Let's make another sketch here. A rectangle. (20 by 20). Fillet 2. Fillet 2. Fillet 2. Fillet 2. All right. Finish sketch. Now, can we move it? So how big was it? Is it 2.8? 9.9. 2.8 and 10. Right? Total was 4.8. I could have saved material by not. Okay, here's the thing. It's a simple block. That's all it is. And I could have saved some material if I didn't print the middle, which I forgot. Okay, that's the only reason. So this is the bottom, right? So it's supposed to basically stick like this. And it's supposed to stick like this. Now comes the main question. Okay. Does it stick here? Wait, if one sticks everywhere, then that means all of them Yeah. So if I move this out of the way, right? And this can go here. This can go here. This can go here. And this can go here. So again, if I move this out of the way, move this here. Yeah, move this here. Move this here. Yeah. Holy fuck, it worked out. Okay, we have this. We have this. I like how it's slightly like rounded. Love it, love it, love it. Yeah. Okay. Dude, there's some lint on like the bottom of it. You see these black spots over here? I should have cleaned the build plate first, but whatever. So it's gonna stick over here, and I'm gonna print one more like this. But so this was 12 mm. Yeah, that's 12 mm. So I need the hole to be at least 12 mm. So let's do. Let's do, because I'm thinking, so let's say the whole plate, the plate which goes on top of this would be something like, so this is almost 5 mm. This is 4.8 mm. Here, whatever. Get it? And then it's going to be 4.8 mm on top of this. And then I'm going to make a 12 mm hole inside of this, basically. Right? So if I go back to the screen, it's going to be like another for another, let's do 0.5 this time as the top layer. All right, and then 2.8 for the whole, and then 0.5 again. That's 3.8. All right, that's 3.8. But that I'm not, and then on the top it's going to be 13. Let's do 13. Do you think it's gonna be able to hold this? I don't know, man. I don't know. If it's not, maybe I just gouge out some material and push. Can I gouge? I mean, if I make a hot knife. I don't know. Maybe I should have put one in between. I'll have to take the magnets out, bro. I'm not wasting any magnets. Let's just move it by 13. Yeah, let's do 13. All right, and let's select the whole thing. Create loft. How does the loft work?
Remember how to do loft number 1, which is the pyramid. Now, this may seem like a complex solid object to create, but I can assure you it's actually very simple. If we think about a pyramid, the bottom sketch is going to be a simple square, a 6 by 6 in the example given here. And then the example also tells us the height is 4 inches. So the height from this square to this point, which is what we're going to use, is 4 inches. Now, to create this point, I'm going to need to create an offset sketch, offset from this work plane by 4 inches, hence the height of 4 inches. I'll go ahead and follow along. I'm going to do that here. I'm going to start on this bottom plane. I'm going to use a different rectangle. I'm going to use a center point rectangle. So it's going to make everything a little bit easier for me. Now I'm going to make these sides 6 by 6. Okay. Now this is done. Now what I need to do is exit that sketch and create an offset plane from that current sketch, which just happens to be this plane here. And it's going to be 4 inches up. Now I have this secondary work plane I just created. I'm going to sketch on that. And since I'm looking down on it, I have the perfect orientation to put the point right over the existing center point. And since I put it right on the center point, I don't have to put any dimensions. So now I have my, since I put it right on the, since I'm looking down on it, I have the perfect orientation to put the point right over the existing center point. And since I put it right on the center point, I don't have to put any dimensions. So now I have my bottom base square and my point. If I go to the loft tool and I select those two profiles, I get my pyramid, just like that. So very simple, straight.
Okay, so let's go to loft. Honestly, yeah, that's what I want, to be fair. Okay. And then I put a 12 mm tube. For that, I need to measure. It's like 8.8. The screw's width, the diameter of the screw is 8.8. So I don't know how this works. From what I saw, let's create a sketch. I'm just gonna do 9 for now. All right. And I'm gonna extrude that. Oh, that's an let's create another sketch. Let's do this. Let's do 9 mm. All right. And let's just extrude this. Let's finish the sketch. Extrude this to 12 mm. Press enter. Oh, actually, let's just get the body out. Then extrude. Body. Move. 1. Enter. Extrude. 12. Enter. All right. Now let's create a screw thread. I don't know. I really don't fucking know, bro. Like, I don't know what I'm doing. I'm just gonna do this. And this looks like a corkscrew. So I just Googled a bunch of shit. I don't know. Modeled. This seems like I want to do what I want to do, but I'm not absolutely sure. Looks okay, I guess. I mean, uh, you know what? I'm just gonna say, okay. And there you go. We have this thing. Now let's take the whole body. Let's move it up again. Now let's show the body too. Screwed. Okay, let's use this. Let's use this. Let's extrude this to negative 0.5. Why did it cut into it? The fuck? Oh fuck, brother. So let's do 5, 0. Let's do extrude. Point. Let's do 0.5 again. And let's show this body. Let's move this. So that's 3.8. seems like 3.8. Okay. Now we have a problem. So, I mean, this is good. This is fine. I can fuck off, man. We have the holes and everything. We have the screw hole. That just seems it. I'm just worried that it might not hold the whole thing. Just gonna 3D print this. Export. My bad, bro. Selected body. Okay. Arm holder. I don't know, bro. I'm not good at giving names. Do I have? Okay. I have it. Let's just also, export STL arm holder just so that I don't miss it. And export iPad plate final export. Okay. Now let's go here. Let's go to file, open project. Let's do arm holder. Let's do slice plate. The fuck is that? Oh, because it's a screw. Oh, dude. This is going to be interesting. So, this is fine. Within 15 minutes. Add pause. Yeah. It says half an hour. Send it. We fucking send it, brother. Damn, brother. This is going to be interesting. I have to like put in the magnets in like a bit, but whew. You know what? It's pretty late right now. I'm gonna see you guys tomorrow. And I'm gonna let you know I didn't clear the bed. Oh, fuck it. I'll just cancel it. Yeah. Form, yeah. Send it, brother. And yeah, I'm just gonna see you guys tomorrow. Bro. Hamter. All right. I'm gonna go to sleep now. Wait, did it fail again? No, right? Felt strong. Oh, okay. All right, guys.